I'd like to welcome everyone to the webinar series of the Cybersecurity and Information Systems Information Analysis Center, CSIAC. Today's presentation is entitled Missile Defense Agency Software Assurance Approach. My name is Steve Warzala. I'm the CSIAC Outreach Manager. Just a few administrative notes before we begin. First, all phones have been muted except for the presenters. Questions may be asked at any time during the presentation by utilizing the chat function. And time permitting, your questions will be answered at the end of the session. The briefing slides and webinar will be posted on our website within a couple of days. Finally, I'd like to take a moment to acknowledge and thank our sponsor, the Defense Technical Information Center, DTIC. The funding DTIC provides enables CSIAC to conduct these webinars. It's my pleasure to introduce our presenter for today's webinar, Dr. Lamonte Green from the Missile Defense Agency. His current involvement ranges from software acquisition policy to cybersecurity engineering. Dr. Green has led several high-performance teams, including the MDA's Software Assurance Pilot Program team. This team led the agency as a pathfinder for the Department of Defense to demonstrate how all DoD agencies' business practices and engineering functions require modification in order to bring them into compliance with public law and DoD requirements. Dr. Green received his PhD in electrical and computer engineering from Carnegie Mellon University. I will now turn the presentation over to Dr. Green. Good morning, Lamonte. The floor is now yours. I think you're still on mute, Lamonte. Dr. Green, are you able to unmute yourself? Okay, we're having a little technical difficulty. Dr. Green, if you click on your microphone symbol to unmute yourself. Okay, if that's not working, you may want to try calling in on your phone if you can't unmute.
How about now?
We hear you loud and clear. There you go.
The presentation demons have struck in, and let's hope that they don't rear their ugly head again. Thank you all for your patience, and thank you, Steve, for the introduction. This is hopefully it's not going to be the sign of things to come, but I do thank you for inviting me to brief the Missile Defense Agency's software assurance approach to the CSIAC audience. I think this presentation may take on additional weight as we in the federal sector are continuing to digest the executive order involving cybersecurity that President Biden signed a few weeks ago. everyone who has read it, we are aware that wide sweeping changes may be on the way that cause all of our organizations to adopt some important cybersecurity best practices. I believe that cybersecurity relies on the quality of software that enables our systems. And I think software assurance is a key best practice that will help all of our software to be more secure. So I'm going to dive right into the agenda. The objectives of this presentation are to provide an introduction to the topic of software assurance and provide an overview of what we did at the Missile Defense Agency to implement software assurance throughout our systems engineering cycle. There are really two pieces to this presentation. In the first part, it really frames and motivates why I think this topic is important. The second part really describes our approach that we took to incorporate software assurance all throughout our engineering and business practices. So, what is software assurance and why in the world do we need it? Software assurance is really the level of confidence that software functions as intended and is free of vulnerabilities, either intentionally or unintentionally designed or inserted as part of the software throughout its life cycle. This definition, software assurance, it's actually a big deal. It's such a big deal that the definition was codified into our nation's laws. As shown, it's only the second time that a law focused on software assurance. And in fact, the first time that software assurance appeared in our nation's laws, it was used to direct the Secretary of Defense to develop and implement a strategy for assuring the security of software and software-based applications. In essence, what the law is mandating is that systems like the ones that we create and field at the Missile Defense Agency incorporate software assurance. So I want to look at this definition of software assurance a little bit more closely. First, notice that software is at the heart of software assurance. And what we mean by software is not only the code that is written by a developer, but it also has to include the open source code and the commercial code and the third-party developed code and the auto-generated code. We want all of the instructions, and I mean all of the instructions that make up an executable. Next, the definition shows that it has an aspirational goal of software that's free of vulnerabilities. Vulnerabilities are weaknesses in the security procedures and the internal controls or the implementation of security control that could be exploited by an adversary. So what the goal of software assurance is software that's free of exploitation. Another part of the definition explores the vulnerabilities a little bit further. It's a recognition that the source of a vulnerability may or not be on purpose. A malicious developer could purposely use a vulnerable library in creating a functionality. Or a library could be incorporated into developed code that is discovered to have a vulnerability. So vulnerabilities could be intentional or unintentional. Another part of the definition focuses on the vulnerabilities that have been designed or inserted. It's a recognition that a vulnerability could come from developer's own hand, like a misinterpretation of a security procedure, or it could be inserted during the build process. Another part of the definition focuses on how often we need to look for the vulnerabilities. It says that don't just look at the software once, but look at it at every stage of the software's life cycle while it exists in a system. And finally, Notice that software assurance is defined as a level of confidence. This implies that confidence in the software can vary, and the confidence can be higher or lower based on certain observable factors. So software assurance is an assessment of risk of the security of the software. Notice that when we say software assurance, what I mean by that is that software assurance is really not a single thing, but in my opinion, it's a strategy to reduce the risk of the vulnerabilities that exist in our computer systems software. And why do we need it? We need it to reduce the exploitable vulnerabilities in our field and mission critical systems. And we also need to make sure we comply with law and other DoD regulations. Now, I want to turn your attention to what we do at the Missile Defense Agency. The Missile Defense Agency fields a capability known as the Missile Defense System. The Missile Defense System is an integrated, layered system of elements that are collectively called on to destroy missiles and their warheads before they reach their target. It's meant to defend our deployed forces, our homeland, our friends, and our allies against all types of missiles, whether that be ballistic or cruise or hypersonic. The agency deploys or uses a combination of radars and satellites and missile systems, and it integrates them with a fault-tolerant command and control infrastructure around the world to create a seamless, integrated system. In this integration of all these disparate components around the world, I believe that what we've done here at the Missile Defense Agency is create a system that is in fact the world's largest real-time distributed computer system with sensors and actuators. And like all real-time distributed computer systems, a non-trivial amount of its functionality is enabled by its software. The Missile Defense Agency has embraced software assurance as a key component in its cybersecurity and resiliency strategy. I believe that I'm briefing the CSIAC audience because, like the Missile Defense Agency, many agencies out there have to field software-intensive or software-enabled systems in diverse environments. I also think I'm briefing our software assurance approach because MDA piloted this approach that brought the Missile Defense Agency into compliance with the law and DoD level requirements. What we did at the Missile Defense Agency is adopt a common approach that was useful for all of our systems. And we intertwined that approach throughout all of our policy and contracting efforts. We did this in order to reduce the risk of vulnerabilities in all of our computer system software, no matter where they operated or no matter how long that system had to operate. As I said before, software assurance, in my opinion, is not a single thing, but it's a strategy for reducing the risk of vulnerabilities in our computer systems software. When you think about having an entire agency adopting software assurance into its business and engineering practices, a lot of issues begin to emerge that need to be resolved. It's like manipulating a series of dominoes so that they fall in an orchestrated fashion. The broad concerns could range from having program office oversight or having to involve the contractor software development processes. Also, it could involve what in the world do we do to accept risk by the authorizing official? All of those issues have to be addressed in order to fully incorporate software assurance for a tactical system. And don't forget, software assurance says don't just look at the software once. You have to look at it over and over again throughout the software lifecycle that exists in the weapon systems. So to bring unity into all those competing issues that I talked about in the previous slide, we used a three-step approach to kind of group and bundle those interrelated issues together to first build in software security, and then assess the software security, and then manage the software's security's risk. The first step in this approach says build in software security into development process. And we do this by ensuring that the software assurance requirements are placed on our software development contracts. Once on contracts, we check to make sure that the software assurance requirements are actually performed at engineering technical review milestones and through normal program office oversight. At the second step for assessing software security, what we do is that we're requiring an independent assessment of our developed code. We recognize that although we have best efforts, we could actually miss a vulnerability during the development process. We want a second set of very smart eyes looking at the software in order to reduce the likelihood that a vulnerability was actually missed. Final approach of our software assurance effort involves management of any of the unmitigated software vulnerabilities that were identified. In this step, the program elements document the residual software assurance risk, and they document any mitigation plans. The program elements manage the software assurance risk according to established MDA policy. Again, step 1 builds in software security. Step 2 assesses software security. And step 3 manages the software security risk. Now, what I want to do is dive more deeply into step 1. And I'll bubble up after I do step 1 and dive more deeply into step 2 and then step 3. This slide is representing a high-level view of the engineering and business practices that needed to be modified in order to ensure that software security is built into a system during the development effort at our agency. Reading the diagram starts from the upper left-hand side at the 11 o'clock position, and it goes counterclockwise. The first icon represents agency leadership and the direction that they gave us. Next, there are the software assurance requirements that influence contractor behavior and define software assurance key practices. The next item at the 6 o'clock position represents the software factory, the developer's software factory, or the developer's software development process. Coming out of that process should be those documented key practices and artifacts that represent the proof that the levied requirements were actually performed by the developer. At the 1 o'clock position, the engineering technical reviews represent the major milestone reviews that demonstrate to all the stakeholders that the development effort was done to our satisfaction. And lastly, at the 12 o'clock position, I'm showing that the program element manages the oversight and is engaged over the entire effort. So what this diagram is attempting to show is that through agency leadership, we don't simply bolt on software security at the end of a development effort. Software assurance key practices must be on contract and in use from the very beginning of a software development effort. These software assurance key practices are verified at the engineering technical review milestones and through normal program element oversight. So now, let me dig a little bit more deeply into those engineering and business practices that I'm representing on this diagram. Major policy changes don't happen quickly through the grassroots efforts. Our agency was able to relatively quickly adopt software assurance into our engineering and business practices because our leadership recognized the need and our leadership acted. In fact, since 2019, all of our agency's directors have mandated that each of the program executives have to budget for inclusion of software assurance requirements on all of its future contracts. I'm going to pause right now because that's another very big deal. What this one simple statement put into motion is a series of activities that affect the way that we communicate with all of our potential developers. Something called the Contracts Requirements Package, was updated to include now software assurance requirements. The software assurance requirements that I've been describing are specified in an RMF software assurance overlay. That overlay is what defines the practices for software cybersecurity that the developer must perform. Okay, so for those of you in the audience who are not aware, the contract requirements package is really a compilation of the required acquisition planning products and documentation that's necessary for the development effort and release for a request for proposal. It's really our way of communicating with potential developers what the requirements are for our system in the early phases of the solicitation process. It governs the way the solicitation process, it governs the proposals that are submitted by a potential contractor and how we evaluate those proposals, and ultimately, it governs contract award and the ultimate statement of work. Since 2019, our new software development efforts include now language defining the activities associated with software assurance. And we did all of that because our leaders recognized a need and they acted. Now I want to dig a little bit more deeply into the software assurance requirements that I identified a little bit while ago. Those software assurance requirements are used to build in software security throughout our life cycles. And as I said on the prior slide, the key software assurance requirements that are put on contract are specified in an RMF software assurance overlay. The reason that we use RMF is because RMF is an existing process for levying requirements on DoD's system development efforts. There are 3 different types of systems at the Missile Defense Agency. There are tactical mission systems. Those are systems that are integrated into the Missile Defense System and are included as part of the operational capacity baseline. Then there are mission support systems. Those are systems that support the development and support the testing and evaluation and monitoring of those tactical systems. And then there are the enterprise support systems. Those are systems that provide administrative support for the agency as a whole. The overlay defines the controls that apply to all of the Missile Defense Agency's software development efforts. But if the control does not apply to the development effort that's being considered, whether it be a tactical system or a mission support system or an enterprise support system, it can simply be tailored out during the normal RMF tailoring process. As you can imagine, more controls apply to the tactical systems than enterprise support systems. So you can expect that the enterprise support systems tailor out more of its controls for its contracted efforts. If you remember, in the definition of software assurance, the last part of that definition essentially says that we have to evaluate software security throughout a system's lifecycle. Engineering technical reviews are one of the primary means that the government verifies that those key software assurance practices are actually integrated into the contractor's development process throughout its lifecycle. At our agency, we have a major policy document that governs our milestone technical review process. That's MDA Instruction 5000.20. This instruction has been updated and modified to include amplifying questions for each of the core software assurance requirements. We now have entry and exit criteria for the SRR, the Systems Requirements Review, the PDR, the Preliminary Design Review, the CDR, the Critical Design Review, and the TR, the Test Readiness Review. All those reviews have been updated to incorporate software assurance into them. We've added amplifying questions to demonstrate that the contractor has actually met the intent of the software assurance requirements that are contained in its statement of work. Okay. And finally, the government verifies that software assurance requirements are integrated in the contractor's development process through just normal program element oversight. The standard software development procedurals, software requirement specification, the software design document, the software development plan, the configuration management plan, and software test plan, etc. All those need to be reviewed now for specific software assurance information that is to be included in these documents. We've modified the requirement to now incorporate software security requirements into the SRS or the SDD or the STP. And we don't just do that. We actually go a little bit further from those standard procedurals that are part of every software development effort. We improve the government's oversight role by defining specific software assurance procedurals to capture the results of software assurance activities. We defined 4 of them. They're the Software Assurance Evaluation Report, the Software Attack Surface Analysis Report, the Software Vulnerability Assessment Report, and the Software Threat Analysis Report. These procedurals are defined in our data item descriptions that feed and work with one another. And we've incorporated and updated, we've incorporated the procedurals into the ASSIST database so that all of our contractors have access to them. First, we mandated that a developer document the software attack surface in the Software Attack Surface Analysis Report. The attack surface is the sum of the different points of attack where unauthorized users could enter data to or extract data from the software. The goal is to keep the attack surface as small as possible. And this report informs all of the other reports that have to be done. Next, the Software Threat Assessment Report is used to document the results of threat assessment activities. Threat assessment not only includes threat modeling, but it also includes threat analysis results. The results from this report inform both the Software Assessment Evaluation Report as well as the Software Vulnerability Assessment Report. The Software Assurance Evaluation Report is the one that documents the tools, techniques, and results of major assessments of software that range from supply chain vulnerability assessments to assessments performed by the commercial tools like static source code assessments, all the way to manual review and testing of cybersecurity functions. This is a major document that identifies all of the major testing activities that are performed by a developer. Its results inform the Software Vulnerability Assessment Report. Now, finally, I've been saying that the Vulnerability Report gets all this data. The Software Vulnerability Assessment Report summarizes the results of all the software assurance activities from all the other 3 reported activities. It has the added benefit of concluding with plans of actions and milestones that need to be taken to mitigate the risks to an acceptable level. Each of those procedurals must be performed at least once during every software development lifecycle. And the current report is to be delivered 30 days before each major technical review. So that completes the description of how the Missile Defense Agency builds in software security. Software assurance requirements are put on contract, and software development practices are actually verified at the major milestone reviews and through normal program office oversight. Okay. Now I'm bubbling back up to the top where we talked about the software assurance approach that the Missile Defense Agency is undertaking. Now I want to turn to the second or the third of the 3 steps, assessing software security. Like I said before, we require an independent assessment of our developed code. Also, remember, I said that there are 3 types of software efforts that the Missile Defense Agency is concerned about: tactical mission systems, mission support systems, and enterprise support systems. The Missile Defense Agency has designated 2 software assurance assessment organizations to support the independent software assurance assessments for all of our software. Both of those organizations have been approved by the MDA's authorizing official to conduct independent software assurance assessments in order to support the authorization to operate decisions. Tactical mission system software is assessed by the JFAC, the Joint Federated Assurance Center service provider. The Joint Federated Assurance Center is a DoD-level assessment organization made up of approved DoD service and agency labs that possess documented expertise in conducting software assurance assessments of critical DoD systems. The other 2 types of software, the mission support software and the enterprise support systems, are assessed by an organization housed in the office of our CIO. No matter the source of the independent verification and validation team, software assurance assessment results are provided to the elements ISSM for use in evaluating software assurance risks as part of the authorizing official's ATO decision. So there are 2 paths for our software. Either we use a JFAC for independent assessments, or we use our internal teams to do that assessment. We do the assessments and provide those results to the ISSMs that inform our authorizing to operate decisions. Okay. This is the last step of our 3-step process that incorporates software assurance into our engineering and business practices. Remember, step 1, built-in software security. Step 2 described how we independently assess the software's security. In this last step, it's an explicit discussion of risk. How do we manage the software security risk? But please remember, I actually discussed risk in the other 2 sections before also. When describing how we built in software security, remember I described that a program element's oversight activities are enhanced by the software vulnerability report. And in that report, it contains plans of actions to mitigate the risk of software. And when I described assessing software security, I included that section by making sure that I said that the independent assessment reports are given to the program elements ISSM in evaluating the software's risk. Software assurance risk has to be assessed, mitigated, and managed throughout the lifecycle, because that's what software assurance requires. There is a multi-step process in evaluating software assurance risk at our agency. Remember that program elements, program office manages the entire development effort. And the risk process then begins in the program elements office when a weakness is identified. Here, a weakness is defined as, is really a deficiency, a flaw, a defect, or a limitation in the code, the design, or the software architecture that could lead to a software vulnerability. In that first step, step 1, in the risk process, a software weakness is identified either by the independent assessment or by the normal program office oversight, like I said before. Once a weakness has been identified in the software, then step 2 of the process flow requires that the identified weaknesses are reviewed by the program element to determine if the weakness represents a true system vulnerability. In this step, it involves analysis of the weakness in light of the system and the systems and the software architecture. It involves making sure that there may be existing security controls or other mitigating factors that may render that weakness to be non-exploitable, especially in the target environment. But if a weakness is determined to be exploitable, then step 3 requires that the program element correct the software or eliminate the vulnerability or mitigate the vulnerability by other means. But if the vulnerability cannot be totally eliminated, then the program element documents any residual software assurance risk, and it documents its plans to mitigate the residual risk. Documenting the residual software assurance risk involves input from technical experts that understand the likelihood of a specific vulnerability can be exploited, as well as the impact on system confidentiality, integrity, and availability if that vulnerability is exploited. Technical experts from across the agency are used to support the technical review of that residual software vulnerability in our Missile Defense Agency risk assessment boards. And lastly, once that software assurance risk for specific residual software vulnerability has been determined, that risk is documented and reported to our executives for final review. So, in summary, the goal of our agency's software assurance program is to improve the integrity of the Missile Defense Agency software and minimize its risk. And it does that by identifying and mitigating software vulnerabilities before its fielding. The agency accomplishes these goals by using a 3-step approach that includes, first, building software security into the development process by levying key software assurance requirements on the contractor, and then verifying those requirements at engineering technical review milestones or through normal program element oversight. It also includes performing an independent assessment of software assurance as part of its software IVNV activities. And finally, it includes managing any unmitigated software vulnerabilities in accordance with MDA instructions. And that concludes my presentation. I think I'm a little bit early, so I welcome your comments and questions.
Thanks, Dr. Green. That was a very informative presentation. It's a very important area. The software assurance is critical to so many systems that, it's just a very, very vital aspect that you're working on here. So we do have some questions, and one of the attendees is wondering if you have any specific tools to manage the overall software assurance process.
Currently, we don't have any specific tools that provide that management of the process. We ask our program offices to just manage the contracted efforts and ensure that all the different software assurance requirements are performed. So no specific tools that provide that automated oversight.
Okay, great, thank you. There's a question on open source reviews and how you might handle those.
Can there be a little bit more specific about the question?
Russ, can you expand on your question there?
Okay, so changes in GitHub. So in our normal contracting efforts, we require that the contractors maintain configuration over all the software that they use in the software development effort. And we require them to document that into the configuration management plan of their normal processes.
Thank you. So there's a question, does the MDA audit software by request if somebody was interested in that? Is that a function that you provide to anyone?
So the purpose of the Missile Defense Agency is to field a tactical system for defense of our nation. There are recognized DoD level laboratories that provide that independent assessment. The JFAC centers that I mentioned before, they are the ones that I would direct the person who asked that question to. They're the ones who have that expertise and mandate to provide assistance to the federal sector, to the DoD in particular.
Okay, all right. So JFAC would be the one to check with that. Okay,
Sir.
Thank you. Yeah. So I as you were giving your presentation, I know that the Air Force is working on Platform 1. So one of our attendees has a question as to whether you currently work with them or have plans to engage with them for cloud native DevSecOps development and software evaluation.
Yes, we are actually talking to the folks in the Air Force right now. We are undertaking a massive effort at our agency to start incorporating DevSecOps practices into our engineering and business activities. Within the office of our CIO, we are building a system that mirrors a lot of the DevSecOps practices that the Cloud One has produced. So yes, we're talking to the Cloud One folks, and their best practices are being adopted by within the office of our CIO.
Okay, and I think kind of related, there was a question about, other agencies have embraced Agile in the development process. So, I mean, if you're moving in the DevSecOps direction, I assume that that's the case for the MDA as well. Then, is that correct?
Yes, that's correct. Many of our efforts are fairly large, so an Agile process works. But if the effort is fairly small, we don't mandate that they use Agile to do the development effort.
Okay, great. Thank you. And so there's a question as to whether there are requirements as to what type of software flaws or vulnerabilities must be fixed, or is that left up to the individual program?
It's a combination of the individual program, but it also involves the authority to operate decisions that are undertaken by our agency's leadership. If we find a vulnerability, we want to mitigate that vulnerability to the smallest footprint as possible. But ultimately, the decision of risk and moving forward is done by our leadership. Our agency doesn't just field systems at its convenience. Sometimes we have to move fairly quickly to defend our interests abroad and at home. And sometimes we have to take risks and deal with the consequences of feeling a risk.
Okay, thank you. So there's a question as to how does the MDA measure the effectiveness of any particular assurance technology as it's applied to a project? Is there something similar to the common criteria EAL levels, or is it a subjective trust of the evaluators, or any thoughts on that one?
The short answer to your question is we assess risk, and you're looking for the definition of what a vulnerability, where a vulnerability could impact the system. We are currently incorporating a key cyber terrain into our cybersecurity and resiliency strategy, and that will be where we will identify some of the more important parts of our systems that need to have more stringent scrutiny.
Okay, thank you. And So now if a contractor is using open source software in their development process, there's a question as to what level of analysis you require the software assurance to be performed on the open source software.
I don't understand the question, actually. Can the person asking the question be a little bit more specific? Until they put in their question, I will respond by saying that when we evaluate software, we look at all of the software, open source, developed, auto-generated, commercial, third party, all of that software. And all that software is put through the same level of assessment, either by the independent assessment teams or that are mandated by the developer, that they have to be performed in the software assurance evaluation reports, either through manual code reviews or penetration testing. All that software has to be evaluated.
Yeah, I think that answered the question. I believe if they were, using that as a component in their overall software development, like you stated, I mean, everything has to get analyzed, whether it's being developed from scratch or an open source piece. So I believe that answers your question. So thank you. And let's see. It says, are there any defects, errors, or identified by independent testers before the executive takes further actions?
Can you repeat that question? That one didn't really hit home for me.
Okay, it said, are the defects or errors identified by independent testers before the executive takes further action?
Okay.
So
let me discuss this in that risk process flow that I described before. Am I still presenting?
Yes, I think so.
Let me back up then.
Okay.
To this process flow here. I think this will answer the question by that member of the audience. The risk process flow starts at the program element office. And if there's a weakness that's found in our software, either by the independent assessment team, right, from the SIV&V activities, or by the program office personnel, or by the developer of the software, all those organizations have the opportunity to identify a weakness. What the question is talking about right now is a deficiency or flaw, a potential deficiency or flaw, a limitation of the code design that could affect the software's vulnerability. The question is asking for the next step here by saying that if the weakness is actually a vulnerability. So within the program office, they have a few tools available to them. They can either mitigate that vulnerability, redesign that software to get rid of that vulnerability, or they can accept as a little bit of that vulnerability and go forward. That's how the process works. Within the program office, they have the ability to get rid of that vulnerability before it enters the risk management process that the executives have to deal with.
Okay, thank you. So there's a question as to whether suppliers are required to deliver complete and authentic system engineering artifacts in the, say, digital engineering with model-based systems engineering concept as part of their deliverables?
I don't think I'm pausing right now as I'm thinking. We don't specify the manner in which they deliver their artifacts. We just specify that artifacts be delivered. Whether they are complete or not is up to the program office to determine if their products are appropriate. But at those major milestone reviews that are undertaken, the worthiness of those products will be scrutinized by all the stakeholders. So it's up to the program office to accept a partial product, but it's also incumbent upon the program office to make sure those products are as complete as possible because of the stakeholders that will have the opportunity to assess those products that were delivered.
Great, thank you. So there's a question regarding step 1, and it asks if the developers are required to create a report, such as a software threat analysis report, and then in addition, are the developers part of the review process, like a critical design review, and how long do these reviews typically last? Okay.
That's a multi-part question. I heard part of it, and as I was thinking about the answer, I missed the second part of it. Okay. So let me first deal with the first part of it. Are the developers part of the process of the threat assessment? So if you remember in how we are building in software security, what we are requiring the developer do is we enhance the development process by requiring the developer also provide reports to us. And one of those reports is the software threat assessment report. So yes, the developer participates in a process because the developer has to create that report. In order to see if that report is good enough for us, that report is given to the program offices, the program element offices, and they are required to accept or reject that report as necessary.
Great, and I think there's just a question about the additional question was kind of like how long, do those reviews, like a critical design review, typically last?
They vary. They vary on the amount of requirements that are part of the review and where you are within the life cycle of the development process. You can imagine that at something called the critical design review, that you're taking a microscope and you're looking at that development effort, and you're trying to determine whether or not all of its design intent has been met. And you're doing that as far as you can go throughout all the different requirements and the intent, and looking at the intent behind all those different requirements. Some of the reviews could take a week. Some of those reviews could be done in a few days. It really depends on the amount of requirements associated with that design review and where you are within the life cycle.
Great. Thanks for fielding that question there. So there's a individual wondering what fraction of your systems developed using this security-centric process and method would you classify as being like classically high assurance, basically formal proofs, things of that nature?
As I'm listening to the question, I don't really fully understand it. I think the questioner is asking me if there are more critical pieces of our software versus others. If that's the question, then the answer is yes. By definition, not all software is as important as other pieces of software. There are other pieces of software that need to have the highest level of scrutiny associated with it. That is part of that key cyber terrain process initiative that's undertaken by the cybersecurity and resiliency strategy that we're undertaking at the agency, identifying parts of our key cyber terrain. You can most be assured that the more important pieces of the software are in the analysis of the key cyber terrain.
Gotcha. So depending on the criticality of this certain portion of the software, you may want to do some higher level assurance utilize some higher assurance methods on those pieces, the most critical pieces. So
Right. And to follow on that question, the implied question is, do we do that? And I won't answer that question.
Okay, fair enough. Now, is there a standard list of common software risks that must be considered in each project's RMF process?
A common set of risks? I think the risks that are identified during the assessment process really come from the CVEs and the CWEs that are compilated by another sister type DoD organization called MITRE. They have those lists are frequently assessed by many of the tools that are developed in the commercial world that assess the weakness of software, like static code tools. So if there's a set of associated risks to software that exist, yes, there are. And the CVEs and the CWEs would be those risks.
Okay. And so now, like for key areas that you've identified for more in-depth assessments, how do you do that? Do you use like a mission-based risk assessment process for cyber, the MRAP-C, or system theoretic process analysis, STPA? Do you use either of those techniques in your work?
I'm questioning whether I should answer that question or not. And I think I can answer it by saying we are considering multiple forms of assessing risk within our agency.
Okay, great. Let's see. Now, can any MDA subsystem be deployed for which the MDA does not have the software, and are binaries evaluated as well?
Binaries are definitely evaluated, and particularly by the folks who have expertise in the area within the JFAC. Remember, we require an independent assessment of our tactical systems. And if software exists only in binary form, it is looked at, and it's done by the folks who have expertise in that area within the JFAC.
Okay, thank you. So there is a question tying back to the model-based systems engineering aspect, and the individual is wondering if most artifacts are in a PDF Word document, or if they're more structured models and machine-readable type data.
You can expect that we're getting a mixture of deliverables from our contractors. And we can specify the different formats for delivery, but whether or not executable is relevant versus PDF, I think really depends upon how the contract is structured and how the program office wants to receive that deliverable from the contractor.
Okay, great, thank you. So somebody who's just wondering if you're either using or considering using EMAS in your efforts.
Yes, EMAS is a standard product that documents most of the POAMs involving cybersecurity risk at our agency. And the authorizing official assesses the accumulated EMAS artifacts and its authorization to connect decisions.
Okay, great, thank you. And one of our attendees is wondering if you have a comparable process or method to deal with hardware and firmware.
Yes, we do standard we do standard supply chain risk management assessments for all of our hardware. And at our agency, firmware and software are completed the same, or assessed the same way. We complete them. We deal with them exactly the same. Firmware is equal to software in our world.
Okay, great. Well, I think we're at the end of our allotted time for today's webinar. I want to thank you, Dr. Green. We had tremendous response. A lot of great questions from the audience. So I think your presentation really resonated with our folks today. So thank you for sharing your time and your expertise with us.
Thank you for inviting me to participate. Also, I must admit that I am only the mouthpiece for a bunch of really smart people who worked on this effort and continue to work on this effort. I'd like to thank all the folks from the Huntsville Joint Federated Assurance Center. They provided a lot of great input for us as we were developing this effort and as we continue to work through some of our issues associated with software assurance. And the folks at the Software Engineering Institute in Pittsburgh, they have a lot of experts up there who contribute countless hours to our agency as we develop the effort. And don't forget the subject matter experts that exist within the agency too, and our leadership in the Missile Defense Agency. They were the ones who had the vision to really adopt wholeheartedly software assurance into our agency, and they've continued to be supportive of our efforts.
Great, thank you. And I'm going to piggyback an announcement on top of that dovetails nicely. So our webinar next month in June is actually going to explore the DevSecOps pipeline for complex software-intensive systems addressing cybersecurity challenges. And our presenter for that is going to be Dr. Carol Woody, who is from Carnegie Mellon University Software Engineering Institute. And that webinar will take place on Wednesday, 16 June. And that one will be starting at 1 p.m. in Eastern Standard Time. So hopefully you can join us for that next month as well. And with that, I want to thank everybody for joining us and have a great day. We'll talk to you later. Bye-bye now.